All right, so essentially they told me that they didn't have any issues with 29. Would you concur? Yeah, then they also told me that 33 was not an issue, right? They told me that 35 is where they started to have some difficulty. So they wanted me to do B, C, and D on 35. I only did B and D. Would you like me to do those? Yeah, okay, so B and D on 35. And then they also told me that 37D was an issue, and that 39, B, C, and D were issues. All right? Would you agree with that? Is there anything else that you'd like me to do? Okay, let me go over those first. I want to be sure that you've got this down pat before we move on with empirical formula work. So let me grab my book. And let's start page 111. Before you do anything, one suggestion, put your calculator in scientific mode. You guys know how to do that? Okay, so you go to the mode button. First of all, I got to turn it on. You click mode. And then you see this menu, how it flashes. You want to put the cursor over psi, right? Instead of on normal. You want it to be over psi. Hit enter. When you have your calculator set that way, it will always give you your answers in scientific notation. And that's going to be a big benefit for a lot of you guys. What scientific notation does is it gets rid of any of the insignificant zeros. It makes it a lot easier to report answers to the right number of sig figs without making mistakes. Because what I found in first period is that students were still not quite recognizing that leading zeros were insignificant. All right, they were counting them when in fact they shouldn't have. So it's just easier to set it to scientific and be done with. All right, so let's start with question number 35B. 35B asks, what's the mass in grams of 7.70 times 10 to the 20th molecules of caffeine? Oh no, sorry, wrong question. It asks how many moles of chloride ions are there in 0.2550 grams of aluminum chloride. All right, so let's start with writing the formula for aluminum chloride. All right, so what's aluminum chloride? What's that formula? AlCl3. All right? Okay. What they're telling me is that I've got 0.2550 grams of AlCl3. You notice that when I draw these fence posts, I always put a number, a unit, a substance, all right, in every box. That's really critical for this kind of work, all right? What do they want me to change this to? They want me to change this to moles of chloride ion. All right, so how do I write the symbol for chloride ions? Cl minus. All right? So unit, substance. I'm going to generate the number in a second. All right. What unit is king in this classroom? The mole. The mole is king for any chemist. From now till the end of the year, any time that you're given a unit that isn't a mole, by default, I want you to convert it to mole. Okay? Doesn't matter what kind of problem we're doing, always convert to moles. That should be your first step, regardless of what you're being asked to do. Okay? So that's the first thing I'm going to do. I'm going to change this to moles. So I'm going to put grams of aluminum chloride on the bottom, moles of aluminum chloride on top. All right, and then I'm going to ask myself, how does the mole of the aluminum chloride relate to the gram of aluminum chloride? Where would I get that information? From the periodic table, right? So I know 1 mole of aluminum chloride is equal to the formula mass of aluminum chloride off the periodic table. So what do I do with the periodic table? I take the mass of aluminum, right? What is that? I can't read that. 26.98 plus 3 times the mass of carbon, 12.01. And what does that mean? So like 133.3? Okay. When you take numbers off the periodic table, take 2 decimal places for those masses and give 2 decimal places when you add them up. All right? So grams of aluminum chloride cancel out with grams of aluminum chloride. I'm left with moles of AlCl3. That's still not the unit that I wanted for the answer. They're not the exact same thing. It is the same unit, but it's a different substance that I want in the answer. All right, so I have to do one more fence post over here. I'm going to have to get rid of mole of AlCl3, right? So I put that in the denominator. What unit would I put above? Mole of Cl. All right, I always start with units first, and then I ask myself, how does that top number relate to the bottom number? All right, so Adit, you were just telling me there are 3 moles of Cl for every 1 mole of aluminum chloride. You got that information straight from the subscripts, right? There's 3 Cl's for every one of these entire things. All right, so now what I do with my calculator, I do 0.2550 times 3 divided by 133.33. The answer that you should get, let me do it. Some long number on the screen, all right? How many sig figs do I write? If you don't know, stay consistent with your given. How many sig figs were in your given? There were 4 in the given, so how do you round this to 4 sig figs? This would be 5.738 times 10 to the negative third moles of chlorine. Okay? And that's how you do that particular problem. All right. What's that? Oh, that was B, not D. All right, let's do D now. D is asking, what's the molar mass of cholesterol if 0.00105 moles weighs 0.406 grams? Okay, so what is the molar mass? When you calculate the formula mass from the periodic table, you're calculating a molar mass, all right? So by definition, the molar mass is the mass in 1 mole, right? Isn't that what a formula mass tells you? The mass of a substance based on its formula in 1 mole? What are the units for molar mass? The units are grams per mole. All right, so guess what we're going to do with the information that they're telling me here? I'm just going to go ahead and substitute 0.00105 moles in the denominator and 0.406 grams in the numerator and reduce, all right? So if I reduce those values, 0.406 divided by 0.00105, I get that. All right. How many sig figs do I write? 3. So because this up here has 3 sig figs and this down here has 3 sig figs, these zeros in the front do not count because they're leading. All right. People in first period were telling me that had 5 sig figs. No, it's only 3. Okay. All right. So how do I round what my computer screen tells me to 3 sig figs? It would be 3.87 times 10 to the second, or if you like, you could write 387. What's the unit for that? Grams per mole. Okay? Yes, Adi? That works as well. Takes a little longer. You don't have to. So long as you know the definition is grams over mole, you take the grams that they give you divided by the moles that you have and you're done. Okay? But you'll get the same answer. But that was a clever way of using your algebra knowledge to figure that out. All right, let's take a look at question number 37. Question 37D, they had some issues. It tells me that you have this stuff called alicillin, and it's the compound that's responsible for that smell, garlic smell. The formula is C6H10OS2. Part D is asking how many atoms of sulfur are present in 5 milligrams of this C6H10OS2. So I start with that given. I want to take that to atoms of sulfur. All right, first things first, I really don't like the milligram unit. Okay, so how do I get rid of it? I know there's 1,000 milligrams in 1 gram. All right. So you could do it as part of a fence post, or I could have written that as 5 times 10 to the negative third grams to begin with, just to save myself a step. So milligram cancels out with milligrams. All right, so grams of C6H10OS2. All right, next. What does a gram unit mean to me? It means absolutely nothing. What unit is king? The mole. So once you've got it in grams, convert it to moles. That should be like gut instinct. That's the first thing you do. So I have to get grams of C6H10OS2 in the denominator, moles of this stuff on top. 1 mole of this stuff weighs how much? 162.30 grams. So if I take 6 carbons, 10 hydrogens, an oxygen, and 2 sulfurs off the periodic table and add them together, that's what I get. Okay, great. Now, final step. That's still not the same as that, right? I still have to go a couple more steps to this. And I ran out of room here on my paper, but it's okay. I know that 1 mole of C6H10OS2 has 6 moles of, 6, why did I write 6? 2 moles of sulfur, right? That's going to cancel out with that, and now I'm talking about sulfur instead of this anicillin business. And then if I wanted to change moles to atoms, I'd have to go one more step. 1 mole of sulfur has Avogadro's number of atoms. Okay? And now that's my entire setup for this particular problem. So you're going to do 5 times 2 times Avogadro's number divided by 1,000 divided by 162.30. And the answer that you should get, well, I don't know what it is because we didn't do it. What'd you get? 3.71 times 10 to the 19th atoms of sulfur. All right, 3 sig figs, like my given, 3 sig figs. All right, questions? These fence posts are modular. You can keep going indefinitely. You're just massaging the number from one unit to the next one. All right? And you put as many pieces as you see fit to get you to the unit that you want to end up at. All right, let's take a look at question number 39. And I'm gonna go on a little diatribe for a second about how to do things. You guys know I'm all about procedures, right? Kind of OCD. I like things done a certain way. Most science teachers do. 39. It's telling me that I have a sample of glucose that has 1.250 times 10 to the 21st carbon atoms. So part A is asking how many atoms of hydrogen does this contain. Part B is asking how many molecules of glucose does it contain. Part C is asking how many moles of glucose does it contain. And D is asking what is the mass of the sample in grams. Okay. Let me show you how I would do it. So B, C, and D. I would start, it's going to take a little bit more time and a little bit more paper to do this, but I would start all 3 questions with the same given. And some people might think that's a waste of time. That's fine. All right, so part B is asking me to change this to molecules of glucose. Part C is asking me to do moles of glucose. Part D is asking me to do grams of glucose. Okay, so why are they telling me that it's a waste of time? Some of these things you could actually take the answer for part A and feed it into part B and do a much shorter fence post than what I'm going to show you. Okay? Why is that a bad idea? You mess up on A, you mess up on B. Okay? Now, in practical terms on the AP exam, does that really hurt you? No, because the readers, they're kind of told that if a student messes up in part A and feeds that number into part B but does part B right, to still give the point. So it's not going to like count against you twice. They don't believe in counting against you twice. But in the lab, it could be a big issue. All right. How do you avoid carrying mistakes? The way that you avoid carrying mistakes through multiple part problems is just to always start with the same initial given. All right. Start all your problems with the same first given, and then you'll never carry through mistakes. All right. Does that mean that it's going to take you longer? You might have to repeat some calculations in subsequent fence posts? Yeah, absolutely. I'd rather you take longer and take up a little bit more space on paper and lead and do it right than carry mistakes through. All right? I'm sure you guys have met lots of frustration with that particular issue in your pre-calc classes, right? When you take, oh, look, Anna's making a face. Right, so you make a mistake in part A, it feeds into part B, you get hit for it twice. We don't want to be in that situation. Okay. And you fail the test because you basically got dinged 20 times for the same mistake. Okay. What's that? You draw a picture wrong? Alright, so anyways. You guys are still at it with that torpedo in the boat? Alright, okay, so. Okay, anyway, that's enough of the torpedoes. I'm sorry, I did not mean to bring up the torpedo, that T word. All right. Anyways, let me show you part B. Shh. Okay, guys, come on. I'm going to take you the scenic route with part B. Okay? All right, so first things first. My gut instinct tells me to convert this to moles. All right? So that's what I'm going to do. And some of you might think, Dr. J, that's so stupid. Why are you doing that? Just humor me. All right? It's just my gut instinct because I've trained myself to do that because I'm all about procedure. All right? So anyways, I'm going to do carbon atoms in the bottom, moles of carbon in the top. All right, how does this relate to that? 1 mole has 6.02 times 10 to the 23rd carbon atoms. All right, next. 1 mole carbon has to go in the bottom so that unit cancels out with that one. I'm going to have to put mole, why did I put 1? That's stupid. I have to put mole C6H12O6 on the top. What's the relationship between the mole of carbon and the mole of glucose? There's 6 moles of carbon for every 1 mole of glucose. All right. Okay, last step. I have to go from mole of glucose to molecule of glucose. All right, what's the relationship between mole and molecule? There's 1 mole of glucose. There's how many molecules in that? 6.02 times 10 to the 23rd. So then we're going to do 1.250 to the 21st times Avogadro's number divided by Avogadro's number divided by 6. All right. So some people had problems last period that I made this conversion here. But it's okay. We all get to the same answer. Okay? And I'm not going to calculate it for you. So long as you have the setup correct, we're good. All right, next part. Could you take this answer and figure out how many moles it is? Sure. By just doing a one-step fence post? Yeah, you could. I'm not going to because what if I made a mistake up here? If I made a mistake up here, I'm going to make the mistake again. I'm going to carry the mistake in the second part. So I like to always go back to my original given in the prompt. All right, so again, I have atoms of carbon. That's not a number that my gut tells me to keep. My gut tells me to just start off by converting to moles. That's kind of, I'm on autopilot, by the way. After so many years of doing this, I'm on autopilot. I want you to be on autopilot too. All right, so anytime you're given a question and a problem, first thing that you should try to figure out is how do I get this to moles? Because once you have that number in moles, then you can do whatever you want with it. Okay? All right, now, I'm going to put mole carbon in the denominator, mole glucose on top. There are 6 moles of carbon for every 1 mole of glucose. Look, I'm done. So basically, part C was part B without that last fence post, that last part of the fence post. Okay? All right, then let's take a look at D. All right, well, Again, I could have taken the answer for B and fed it into, I'm sorry, for C and fed it into D to get the answer, and I could have done it in one step, but, you know, I don't like that. So I'm going to go back to the beginning. I'm going to take my carbon atoms and convert them to moles of carbon. Then I'm going to take my moles of carbon and convert them to moles of glucose. Okay, now, how do I go from moles of glucose to grams of glucose? What instrument can I use to help me with that last part? You use the formula mass off the periodic table. You know, 1 mole of glucose has what kind of mass? It's 180 point, what is it? Guys, I know it's 180 from memory, but what are the last two decimal places? Is it 18? Okay, grams of C6H12O6. All right, so again, you multiply across the top, divide across the bottom, and you get your answer. All right. Questions? No? We're good? Okay, great. Let me pause here.